Hey, good people, welcome back. This is Arthur Morris. I hope that all is well with you today. In this video, we're going to look at solving exponential equations, how to solve exponential equations. So this will involve using logarithms. When some of these will, if we can rewrite the equation in the form of b to the m power equals b to the nth power. In other words, make each side have the same base, then we can set the exponents equal to each other and solve for the variable. If we can't, then we want to isolate the exponential expression, take the natural logarithm on both sides of the equation, and then simplify and solve for the variable. So you may want to pause and jot this information down. Okay, so let's look at a couple of examples. This first one, we want to solve the exponential equation by expressing each side as a power of the same base and then equating the exponents. So in other words, we want to see if we can make both sides have the same base. We have 4 to the power of x equals 64. So if I can make that 64 have a base of x, I can easily solve this equation. So I know 4 to the first power is 4, 4 to the second power is 16, and 4 to the third power is 64. So I can rewrite 64 as 4 to the third power. Now, since those bases are equal, then the exponents must be equal as well. So I can simply say x equals 3. Okay, so let's look at another example similar to that one. The second example below there, we have 2 to the power of 2 minus x equals 1 over 8. Now, keep in mind your reciprocal rule for exponents. So I know that 2 to the third power is 8. Therefore, 2 to the negative third power using the reciprocal rule for exponents is equal to 1 over 8. So now I can rewrite this as 2 to the negative third power. And since they have the same base, I can now set those exponents equal to each other and solve the equation. So subtract 2 from each side and then divide both sides by negative 1. We have x equals 5. All right, let's take a look at this one. Now this one we have this exponential equation, and it says to express the solution in terms of natural logarithms or common logs, then use a calculator to obtain a decimal answer. So since we have e to the x, we want to get the x out of the exponent area. To do that, we're going to take the natural log of both sides. Now, we know that the natural log and e are inverses of each other, so that would just give me x on the left-hand side of my equation. Now, this is called an exact answer. However, it also asks for me to find the decimal approximation. So using your calculator to find the natural log of 13.23, we get the approximation of about 2.58. So keep in mind the difference between an exact answer and a decimal approximation. Okay, so on this next one, we're going to do the exact answer only, and you can use the calculator to find the decimal approximation. We have 3 times e to the 5x, power 5x, equals 303. So we would divide both sides by 3, to isolate the e to the power of 5x. And then we want to get the x out of the exponent area, the variable x out of the exponent area. So we're going to take the natural log of both sides because, again, the natural log and e are inverses of each other. Now the natural log and e are inverses of each other, so that just leaves us with 5 times x on the left-hand side of the equation. Let's make sure we take the natural log of that 101 as well. So now I have 5 times x equals the natural log of 101. Divide both sides by 5. And we see that x is equal to the natural log. And keep in mind, natural log, that is a lowercase ln, natural log of 101 divided by 5. And again, you can type that in your calculator and get your decimal approximation of about 0.92. Okay, let's take a look at another problem here. In this particular problem, we have, we want to solve the exponential equation and express the set in natural logs or common logs, and then estimate decimal form, right? So we have 3 to the power of x plus 3 equals 2,849. Now, I'm not sure if we could raise 3 to some power to equal 208,049. So the easiest way to do that is just to go ahead and take the natural log of both sides, and that will allow us to pull that exponent of x plus 3 down from that position. All right, so now I can use the power rule for our logarithms and pull this x plus 3 down as a factor, multiplying times the natural log plus 3. Okay, and now we're trying to solve this for x, so I want to divide both sides by the natural log of 3. And then the final step to solve for x, I have x plus 3, so I want to subtract 3 from both sides. And that would be our exact answer. That's our exact answer. If it wants a decimal approximation, again, you would do that in your calculator to find that decimal approximation. Let's see what that is. And that will be approximately 4.24. All right, let's look at one more example in this video. All right, in this one we have e to the power of 4x minus 5 times e to the power of 2x minus 14 equals 0. So we're going to have to use a little bit of our factoring methods here. So I know that factors of negative 14 that equals negative 5 will be negative 7 and positive 2. So I can factor this expression on the left-hand side and breaking up the 4x to 2x, so e to the power of 2x minus 7 times e to the power of 2x plus 2. So I just use the techniques for factoring trinomials there, multiplying finding factors of the last number that also gives a sum of the middle number there. And then to solve this, I would set the factors equal to 0. And then solve each one. So on the left hand side here, I'm going to add 7 to both sides. And then I want to pull that x out of the exponent area. So I'm going to take the natural log of both sides, because remember, the natural log and e are inverses. So the natural log of e to the power of 2x is simply 2x. Now I can solve for x by dividing both sides by 2. Which approximates to be about 0.97. Okay, now let's solve the second factor here. Let's solve the second equation, e to the power of 2x plus 2 equals 0. Okay, so we want to subtract 2 from both sides. And we'll follow the same process. We need to get the x out of the exponent position there. So we will take the natural log, find the natural log of both sides of the equation. Now, herein lies the problem. Remember that the domain of logarithmic functions, are positive numbers. Therefore, I cannot take the natural log of a negative number. And since that's not possible, then I can't get a solution out of this side here. So since I cannot take the natural log of a negative number, I won't get a solution from that factor. So my final answer is, the exact answer is x equals natural log of 7 over 2. And the approximation for that is approximately 0.97. Alrighty, good people. I hope you found this video to be helpful. I'll see you on the next one. Thank you.